Hi students, welcome to Year 9 Science and Unit 1 Atoms and Stuff. This is getting to the end of our look at chemistry and also the periodic table. So what we want to do today is just to have a little bit of a zero in on periodicity to follow up from the work that you were doing yesterday. This particular video sits into the area of where you can relate the properties of some common elements to their position in the periodic table. We have looked at the organization of the periodic table and some of the history, and it's really important to understand exactly why the elements are positioned in the way that they are. And periodicity is a really important concept in order to understand how the elements are organized the way they are. So periodicity specifically relates to the cyclic nature of something. So lots of things demonstrate the property of periodicity. Even just a pendulum which swings backwards and forwards at a consistent rate is demonstrating this property of periodicity. It just means something that recurs on a regular basis. And yesterday we had a look at atomic radius as a particular periodic property. So here is actually one of your work. So this is where I asked you to plot atomic radius against the element or atomic number. And you can see what this student has done is used a bar graph. You could also, or column graph, you could also have used a line graph, which would have also showed this pattern. But what we are seeing is that as we start each period, so period 1 has just hydrogen and helium in it, and then period 2 runs from lithium all the way down to neon, and then period 3 from sodium all the way down to argon. And if I draw those little lines in, you can see that this is a very consistent pattern. Now there's a couple of important things to notice about the patterns when we're looking at periodicity. The first and the most important thing is this recurring cycle. The recurring cycle is important because what it does is it shows us that something is happening with the elements when we plot properties that happens consistently. It's happening over and over again. And we've only gone to the first 20 here, and the patterns do get a little more complicated with the more elements that we put in. But we can also see not just patterns in relation to the periods, that is the rows that go across are called the periods, but we also see patterns in the groups. And the groups are the ones that come from the top down. So I can pop hydrogen in there as an example of group 1, but I also have lithium and then sodium and then potassium. You can actually see these ones are going up. Likewise, if I were to pick the noble gases, which might be helium and neon and argon, again, there is it's probably less easy to see, but there's still an upward trend. So atomic radius is a property that we can see occurring or having patterns in its periodicity, in its consistency of pattern, but we can also see some interesting little trends as we look at the particular groups. Now, atomic radius is an easy one to explain because if we think about the way that the electrons are organized, as we go to each new period, we start a new energy level, or we start a new shell. So the electrons get further and further away from the nucleus. This makes sense if we're looking at atomic radius as something that gets bigger and bigger as you go further and further out with your electrons. It doesn't necessarily explain why they get smaller as you go across a period, and that requires a little bit more thinking. If we think about the fact that the electrons are being added in the same area that they were before and they will repel each other, we would perhaps expect them to be maybe slightly bigger. But we also remember that in the nucleus, where the protons are being added one by one as well, that's becoming a much stronger attractive force, positive force attracting the electrons. So it actually pulls them in a little bit closer. This is the difference between an explanation, why do you think the pattern is there, and a description, what is the pattern? What I'm going to get you to do today is to have a look at some of these other properties to see what sort of periodicity they can display. So you're going to get a partner to work with, and you're going to be assigned one of these important properties. That is melting points, boiling points, first ionization energy, electronegativity, metallic character, density, chemical reactivity, and electron configuration. So I've allocated each of you one of those, and what I want you to do is to find out what that means. So melting point, hopefully you know what a melting point is, but maybe you don't know what electronegativity is. I want you to find the values for the first 20 elements, and just as you saw the graph on the previous slide, I want you to produce a graph for your particular property. And what you're going to do with that graph then is see if you can do two things. Describe the pattern. What can you see? And the more tricky bit, explain the pattern. Do you have any idea why the pattern is the way that it is? So that's your task for today. Good luck with it, and thanks for watching.